permissions to write in that place. However you get it there, I don't care.
So
as long as it's there, you're fine, right?
So if we were
make the
using
folder
pipe,
first.
a 1-inch pipe, we would actually click on the 1-inch pipe in there.
That's right. Well, you click on it in SolidWorks and it'll make it 1-inch pipe.
Okay, and then,
Okay.
but when we save it to this file, are we saving it to a folder or inside that? Or where are you saving it to
Well,
exactly?
what we wanna do is we wanna save our ANSI2 thing here, which is this one here. See, this one here wants to get saved to this directory.
Okay.
SolidWorks Corp, SolidWorks Lang, English, Weldment Profiles, and whatever name we have. I've got 4 names here, right? ANSI, and then there was only 2 originally, right? There was ANSI Inch and ISO, right? And so I have added the ANSI Inch 2 one and the custom one, which might be an indication of what the second part of the assignment is, right? Okay, I mean, just to give you a little heads up, right? Okay, so that's where we're going, right? Which makes, I think, a certain amount of sense. We're gonna go play with weldments or weldment profiles today. So what I wanna do is I want to get back here, I'm gonna go pick on my ANSI Inch 2. I'm gonna go do the weldment section, the W section, and I'm gonna do W. I can scroll down here to W, and I'm gonna pick a different one just because I'm that kind of guy. Let's pick a 10-inch one here. Why not? Okay, I'm gonna pick 10 by 19, and I say okay. Well, first of all, I need to pick on a group. And the group is which one I want it to join to, and it's gonna go, oh, that's what we did. All of a sudden magic happened. I pick on a group and it built me an I-beam. There's only one minor problem, or W section. It built it in the wrong orientation, built it flat, which I'm cursing, but there is an angle down here on the lower left. I could say 90 degrees, and it'll go 90 degrees. And I don't know about you, but it looks like we have a W section.
So are we all supposed to have W section option under type? Because I don't have a W section.
That's how you download it.
Oh, not to- okay,
That's
that's
how
when
you
you
download
download.
all the others, right?
Okay.
Now all you have is an S section, which is close, but it's, what's the difference between an S section and a W section?
One begins with an S and one begins with a W.
I can tell he works in IT. Okay. So, it's that Microsoft help answer, as I refer to it as, yes, the technically correct and completely useless, right? So,
There you go.
Okay, so that, right, no, the S section,
Car's leaking.
the inside is tapered, like a channel.
Sir.
Right, they're what our traditional I-beams are, originally were considered S sections. The inside flanges are not flat, they're tapered. And that's because when they first started rolling them, that's all they knew how to do. It was hard to do the flats. And so they rolled them with tapers on them, right? So that the inside was tapered like a channel iron. They have an angle, not a very big angle. It's like 15 degrees, but there's an angle on the S sections. The W sections and the HP sections and some of the other more newer sections are all, the flanges are all flat. They're all constant thickness all the way across. And they're the ones that we all use these days. They're much cheaper than the S sections for a variety of reasons. So we do this. So anyway, okay, you can go pick on an S section if you want to follow along. We can pick on an S section. Later you can just go back and change the profile and it'll all work, right? What's that?
It should just come up.
You can just pick an S section.
It should just come up once it's in the language file?
Yeah, well, all you do is you can go in, if you want to, you can go ANSI Inch and pick a, well, I don't have S section over here, which I can go to, because it got eaten by my other topic. I can go to S section here, and I'll have one that looks like, well, I got a whole bunch of them here, but the ones at the top are yours, right? You have 3.57, 4.77, and 5.10, right? That's the ones that you had in yours. It just added on to them. So if I pick that one, right, what's it gonna do? It's gonna give me that beam. And you see, if I zoom in, see how they're tapered? Yeah, it's an S section, right? Okay. So I don't mind that one, that's a fine beam to have, we'll just do that. I mean, to change it, all you have to do is go and edit the object, right, and then go back and change it. It's an easy thing to change at the next time through what's the model, so, right, it's not hard to change. Make some sense there?
Yeah, I don't want that.
So you can build it out of anything proper, and then when you wanna go back and, when you have the new profiles installed, you just go back and reload it and change it, you'll be there. Okay, is that good?
Well, it's okay.
Okay, so I'm gonna say, okay, I've got an S section here, I like my S section, it's actually cool. Okay, so now I've got a perfectly fine section here, I'm gonna go do the simulation, new steady, I'm gonna go beam me up.
Ah.
Okay. Okay, and now we're gonna go, of course, define some material to this. And because I don't know any better, I'm gonna say it's A36. Okay, some nice steel. One of the things you should notice here is that when it created this beam, it went into the model, there are two big balls here. See these big balls?
Poor children.
Always remember, or
Sorry.
two in the, or two in the class, as I say. Yes, okay, okay, so, yes, I'm going to have to, okay, so.
I don't know what IT did.
I'm gonna have to be careful here now, because I'm going to start laughing too badly here, so okay, we're done. Okay, so anyway, we have these are indications of what it calls joints. When SolidWorks makes a model out of beams, it puts joints at the ends of it. There are places where other things can join to, okay? And so it indicates where the joints are in your beam model with these balls, okay? And so we have these, this is a place where we can apply constraints to. We can apply loads to them, we can apply displacement constraints, other things. So let's go apply displacement constraints. You know, if we got very little choices here, we got fixed geometry, so okay. I don't really want fixed geometry, but immovable is not a bad choice. And you notice the only thing I can pick on here is this little symbol over here, which tells me the only thing I can apply my displacement constraints to is the joints. I can't apply them anywhere else. So if I want to apply them in some particular place, I have to make a joint there. Okay, to be able to do that. Okay, so I'm gonna actually do immovable, which is no translation. I don't want to do a fixed geometry because that supports a moment, right? I don't want to support a moment. So I'm gonna do that, and I can just click on this ball over here, or I can even get somebody's favorite guy up here, right?
Oh.
Okay, so that, and I have the one that's, I have guys on the end here, right? And I can make the arrows big so that everybody's happy, right? Okay. So I've got one end fixed, and now if that was good, I can do it again. Now, I can't make this one immovable because it's a roller, right? And it doesn't want to support it's allowed to move in the X direction in this particular case, right? So we need to support it in the Y direction and the Z direction. So I'm gonna do the use reference geometry here, which is always a good one. I'm gonna pick on this other end over here. I'll rotate it around a little bit. I tend to like to pick a plane that makes myself convenient. So in this particular case, I'm gonna use the right plane for the coordinates, because if I fix the in-plane ones, and I'll make the arrows big again, right? What's not showing me the preview there? Okay. That's stubborn of it. Oh, I had collected those, okay. There we go. I didn't want the rotation components, I wanted the translation components. I did select them. Darn thing is stupid as can be. these two displacements on the ends. It's supported in the vertical direction and it can't move out of the plane, right? Those are the two constraints we have on it, right? So we can see it's supported this way, it can't move out of the plane. This one's supported in all three directions. Okay, that's good, isn't it? Easy peasy. Did it get any easier? Okay, now what do we do? Loads, loads. Okay, so let's look at my problem. Right, what did I have? Ooh, I didn't, who needs handouts? There's some, oh, we got, handouts. Handouts, yes. Yes, okay, so, okay, so it looks like I need to put.
One more.
Oh, did I forget? Did I have one? Oh, sorry. I didn't realize.
Syra gave it.
Syra grabbed it. Oh, okay.
There you go.
Now you have
I
two.
there, Jimmy. I have to give Syra a bad time there. So, okay. What are we doing now? It looks like we gotta move over here. We got 4 foot of 5 kips load and 4 foot of 8 kips load. Okay, and so I go over to my model and I go, okay, let's put some loads on here and I want to put a force. And it goes, well, I've got a choice of vertices or points, or I can put it on joints, or I can put it on the beam. So I go, I'm going to put it on the beam. And it looks like when I click on the beam, I get the whole thing, which you sit and look at and go, expletive deleted. Did that instructor really do that to me?
Yes.
And the answer is, of course, yes. So what do we have to do? Well, okay, I split it and I look up here and all those tags for splitting aren't there. So, okay, yeah, darn it. So what we have to do is I'm gonna have to go back to my model and edit the sketch. And instead of 44, I'm gonna make this something like 48. Alright. And I'm gonna get Brian's favorite thing up here. And then I'm going to draw another line. And then I'm gonna draw another line. Okay?
The one where you go left, right.
And,
Oh, yes.
and I'm gonna dimension them where they're 48 and 48.
You're just doing 48, you're very different.
Because I'm always, yes, I have to be a little bit odd, right? Okay, then I get out of the sketch, and then I have to go in and edit this guy, that's this one, and in the group down here, pass segments, I've gotta click on these other ones. So in this path segment in your group, where you're defining one of those, you have to pick other segments. And so now I've got 3 segments.
It's not all day yet.
And I can say, okay, and I have a beam that's now the same length, but it's broken up into 3 chunks. We find that? So wasn't that a hard edit? You guys can accuse me of making this model hard because instead of drawing a line, you had to draw 3 lines. It's 3 times as hard. I cannot refute that. However, it doesn't take 3 times as much work in creating the weldments, right? Because you just have to add them to the same. No, you just go into you edit the weldment thing, and then there's a weldment on there, you can edit the feature. And then that'll add to it over here. It's if you see this thing down here where it says S section 5 here.
Yeah, I mean.
If I right click on that, are you out of the sketch? Okay. Okay, it doesn't do anything if you're not in this, you're not out of the sketch, right? So that's, I've lost count of the number of times I've done that. So, okay. Okay, So now we have it over here, we could go back to our beam stuff. Now we've got problems because it looks like our displacement constraint is here instead of out here on the ends. You see the joints, the big balls, we got lots of balls now.
It's been a long day.
So, he's having a hard time, I'm gonna keep using this. dummy.
I know,
That's the-
I know. Balls
that's the-
everywhere.
That's it. You know.
So we did the.
I'm really having a struggle biting my tongue here because it can go downhill real quickly.
Don't struggle on my behalf.
It's already downhill and going worse, so, okay, we obviously need to change this one here because this guy here is now this reference geometry is now in this position. He needs to go out here, so we can double click on him and edit the definition. And of course, we want to eliminate this joint. And we want to go pick on this joint over there. That was easy. Okay? So, we have that one over there. Now we have it fixed at the ends, right? It's all fixed like it's supposed to be, and we have places where we can put loads. Okay, we have sections of the beams we can put loads, so I can come in here and put a force, and now I can pick this beam over here. I'll have to select beam first over here, so it'll pick a beam. I'll pick that one. I'm gonna pick a reference geometry. I'm gonna go pick the top plane, just so I can put the force out of plane. Looks like it's coming up from the bottom. I wanna go down, and I'm gonna make the arrows bigger because they're not big enough.
So when you added those two parts, you didn't have to go back and re-add the material and.
Nope. Well, I will have to go back and rechange the material because it's not gonna know what they are, but that's okay. I will have to do that. And this particular case, I've got 5, I'm gonna go 6,000 pounds. No, I'm gonna go 4,000. Okay, just so I'm picking numbers at random here. Okay, and I've got that force on there, and of course, if I can do it once, I can do it twice. And we're gonna go pick on, again, we have to select on the beam option, pick the beam, need a reference geometry, and I typically pick one, oops, it's gonna give me, come on, pick one that gives me, an easy way to pick my orientation. I want to go down, and I'm gonna put, let's say, 6,000 over here, because it's a fun number. We'll make the arrows big. Okay, and so I got 6,000 pounds on this other section over here, and they actually have a per unit length option here that I'm gonna observe because we'll probably need that in the future. So other than that, looks pretty good. We go yes, 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 and I have a load. Okay, a nicely loaded beam. It's constrained. It's loaded. It's taking me a whopping 40 minutes. Well, 30 minutes. And most of that was explaining how to get the weldment profiles. Okay? We believe? No, everybody's far too busy clicking. Okay? Or scowling. So, or both. So now what we need to do is we need to go create the mesh, and when we hit the create mesh button, strange things will happen. Our beam vanishes. And instead,
You get a tube.
we get a tube. And that's because
It's a beam.
it's a beam, and it models everything as a tube, and it goes, I'm not gonna maintain a shape, I'm just gonna give you a blob, okay? Tube, okay, so that's what we have, is we have a tube, that's all it gives us a nice tube. Now we hit run the study, and
No material.
the material is not defined, and that's because, of course, I only defined it for one section. So we go back in here and apply material to all bodies, yes, okay. And then we go run, and it goes boom, and we have results. Isn't that nice? Okay, I can drag this out of the way over here, I think. Yes,
But those are pretty
and we have nice
good.
results,
You don't have to
looks
do
like
that.
we have 40,000 PSI in the center. So it looks like I'm going to yield this particular beam. So, am I worried about this?